Our next topic, continuous delivery and its design. I'm sure you know what is continuous delivery. If you don't, I can give you a quick summary. Continuous delivery, who knows what it is? Who ever heard about this, continuous delivery? Okay, so not so many of you know what it is. Continuous delivery, that's the concept, and continuous delivery and continuous integration. We're going to talk about both. But continuous delivery means that you deliver your product to your customers automatically. So it's not like every time you think, how would I do it? What I need to do? But you have an automated process of delivering your product to customers. That's the idea of continuous. That's why it's called continuous, because you can, I don't even know why it's continuous, but it means probably that you do it once, then you do it again, you do it again, you do it again. It's easy, it's automatic. It's like a conveyor where you deliver in one click, basically. The full idea is that you have to have a button which you click, and your product, the new version of your product, is right there. The customer can see it. If it's a web system, then you just click, boom, you open the website, the new version is right there. If it's a mobile app, you click it, boom, on the mobile phone, in the Apple Store, they see, hey, the new version is right there. Do you want to update? And the user says update. That is continuous delivery, which is very hard to achieve if the system is big. It is more or less okay, it's more or less easy right now because we have so many tools right now, but it's easy to achieve for a small application, which you do on your labs. It's easy to achieve comparing to what we had 10 years ago. So 10 years ago, it was really difficult. No tools, it was just an idea. Now we have many tools, it's possible to achieve. So let's discuss. We're going to talk about continuous integration, continuous delivery. I will tell you about open source on GitHub. Somebody asked me a few times about this, like what it is to be open source on GitHub, and then books and venues. So it's not going to be very long, but I hope it will be interesting. Continuous integration. Continuous integration works like this. I found this diagram, which actually makes sense. So the developer puts the code, so follow the line. The developer on the left puts the code in the source control. Source control is Git. So you do git commit, git push, enter. Then the system understands that something new is right there in the repository. The system picks it up, some system, continuous integration system, which is maybe GitHub Actions or Travis or a huge number of other systems. So it's some robot. So the robot is constantly watching what's going on in your repository. The moment you do git push, the robot says, oh, there's something new there. The robot takes the latest version from the repository. And the robot says, let's do build. So it says build. So the system is being built. I mean, tests, compile, everything together. So you run the build, so you compile this. The robot, you make the script for that. So you give the script there. Usually the script stays right there together with the source code. So the robot just takes your new code, finds the script. Okay, here's the script. The robot runs the script. The script does everything, compile, and then test, and then report. So the robot looks at what's the result of the script, and the robot says, oh, something is broken, or no, everything is cool. And then they report. This is the cycle. And again, you push something, the robot picks it up, builds, tests, report. Picks it up, build, test, report. And it happens many times. Every time you push. The original idea was not to do it every time you push, but to do it once a day. That was idea 15 years ago. It was introduced, I'm not sure who exactly, but probably Microsoft. So there was some company, or maybe companies, I will not lie to you, but there will be, that was the idea that we, every night, everything our programmers do, we build at the night. Because it's a big code, at that time computers were much slower, so we compile everything, build, and in the morning, they all come to the office and we tell them, it was broken. At night, we failed to build what you worked. And then all programmers sit together and fix what was broken. And again, next night, we again build everything. We go to the office in the next morning, we look what happened in the night, we see, okay, no bugs, cool, everything is compilable, and we continue to work. That was the original idea many years ago. Then the idea transformed to every time you push, like I said, the robot builds everything, makes the circle.
Is this some deployment?
It's not a deployment yet. It's just build. So don't pay attention to this release line, the green line. We will talk about it later. Now we're talking about only continuous integration. Yeah.
How does it test the new feature like you just updated?
How does it test a new feature?
But you just push on to Git.
No, it's not yet about delivery. It's just continuous integration. So we'll talk about delivery a little bit later. Now we're talking about continuous integration. Continuous integration is we integrate everything in the office without customers. So we don't deliver. Then continuous delivery is about delivery. Continuous integration is just this cycle. I push, you build, inform me. I push, you build, and let me know what happened. That's all. That's continuous integration.
Where's the test step here?
Test means automatic test, unit test. It's not the test with people. It's automatic tests, unit tests. So we just test, we run tests inside your code and test how they work. The problem with this is that it doesn't work. In reality, this stuff doesn't work. So this idea of, I even have a blog post about it, which says that continuous integration is dead, which I wrote probably 7 years ago. Continuous integration is dead. In my opinion, it's dead because this doesn't work, because what happens in reality, if you configure it this way, then it will be always broken. So the build will always complain that something is broken, and nobody will fix it. So the original idea was this: we build what you work with, and if something is broken, then we all stop. This is the idea. If the build fails, the development team stops whatever they are doing and fixes the problem immediately. That's from the book. That's the idea of continuous integration. It doesn't work because nobody will stop and nobody will do anything to fix some build when we have some new tasks to do. So it's utopia. So it's absolutely impossible to stop the whole office. The development team stops. Imagine the development team of 20 people, and they all stop to fix the build which is broken by somebody last night, one person. It's not going to happen. I mean, I've seen many teams in my life. They don't stop. It's just a false objective. So, but this is what we have to do, because if we don't stop, if we don't fix the build, then imagine how difficult it is for other people. Let's say I'm the developer and I break the build. What it means break the build? I introduce some code which doesn't compile. So let's say I open the file, I type some code there which is broken, then I do git push, it goes to repository, the cycle runs, the continuous integration server says, something is broken, I cannot compile, but the other 19 people who are sitting next to me, they continue working. They have their own jobs, they have their own objective, their own files, so they continue doing what they were doing. But the build is broken. And what's important is that they not only do what they do, but they also pull the changes from repository. My changes, which I pushed there. Imagine that we all work on the same set of files. So I make the wrong changes there. I push it to repository. They pull it from there. And they believe that everything is good because it's repository. So we pull and continue working. Nobody will do like pull and then check what is coming from there. Let me check what I just pulled. They don't do it. Nobody does it. We just say git pull, boom, a huge list of changes come to me. I trust these changes and I continue working. But then all of a sudden I realize that it's broken. I cannot make any changes because something came to me which breaks everything. So it's very important to have the build clean, to make sure that the master branch in Git, the main trunk, the development trunk or master branch, whatever you call it, so this place has only the code which I can trust, which everybody can trust in the team. But if we allow everybody to push to master, expecting everybody to stop later if something is broken, then nobody will stop and nobody will trust the master branch. So I will know that anybody can push there, and some team will stop, nobody will stop. So the trust goes away and the team stops working properly. So continuous integration has to work differently. I believe that this idea of this cycle is wrong, but this is a better idea which people call pre-flight builds. Pre-flight builds work like this. This is my slide from one presentation which I made a few years ago. I don't have the link to it, but I can post it below the video later. So how pre-flight builds work? Let's say we have two developers, developer 14 and it's not the developer 14, it's the developer is working on the problem 14 and the developer is working on the problem 45. So they work on two different branches. They have two branches and they call differently. Branch, you know what is branch, right? Like in Git. So it's a branch of development. So I take master branch, the main one, so I branch out, and I start working in the branch 14, and you start working in the 45. Then at some point of time, I think, okay, I'm ready with my changes. I cannot push to master branch. Master branch is read-only. It is protected. So no developer can push to master branch anything. All I can do is I can take my branch, so I cannot merge my branch into master. I take my branch and I go to pre-flight bot, the robot. So I give my branch to some robot and say, how about you try to merge this stuff into master branch? Because I cannot. I have no rights. I mean, I'm trying, but there's access denied. The robot takes my branch, merges into master, runs the build before pushing. And only if it's clean, it pushes to the master. So the robot protects the master branch and guarantees to everybody, to all other programmers, that only the good code will go to the master branch. And then the continuous integration will pick it up and run on the master branch, but it's going to be green always. Always green. I mean, there are two status the continuous integration can give you, the green, the red. So it will be, in most cases, it will be green, 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 green. Only sometimes, only some special circumstances, something is really wrong goes on. Then maybe in this scenario, the build, you see it's going to be green all the time, the build will go red. In this case, yes, we all stop and say, what's going on? Why? Even though the master branch was protected and all the changes were coming through this pre-flight bot and still got red. And in this case, okay, I can understand it may happen once every 3 months, then we all stop and then we fix the master branch. But without this pre-flight test, that they call it pre-flight because before it flies to production, to master branch, we check it before the flight. So before this pre-flight bot, without this pre-flight bot, I don't think it is possible to have anything that looks like continuous integration.
And this pre-flight bot is something automated, so
Automated.
Automated. And these tests are written by the same developer who will push?
No, I think that pre-flight bot, it's a tool. It's something that you install and use. So it's not your software. It's a tool which you can use. For example, the CI server is also a tool. And we're going to discuss which tools, in a few minutes I'll tell you which tools we have. But pre-flight bot is also a tool.
But I mean the tests that, for example, let's say unit test. This unit test will be written by the same developer who will push or by some other developer?
No, the unit test, usually developers work on their own branches. So when I work on my branch, I write my own unit tests, I write my own code. Maybe I can touch the code which is written by other people or other tests. It's okay. I write different, I modify different files. But then they all stay in one branch, and then this branch goes to master branch. So I do not conflict with other developers at that time. We do not overlap anyhow. Usually, that's how it should be. Well, aside from extreme programming, pair programming. When you do pair programming, then 2 people work. But usually it's 1 person.
In this case, what if I write some code and I write weak tests? Or for example, I don't write tests at all.
Yes.
And this will pass the pre-flight code.
Yes, of course, that's a good question. So if you, for example, make the code, which is bad code, yeah, with a mistake, and then you don't write the unit test, then you give it to the pre-flight bot. Pre-flight bot compiles everything because no tests, so everything is good. It goes to master branch. Then I pull your changes to me. It's still clean for me. It still compiles. Yes, it has bugs, but who doesn't? Of course there will be bugs, but they're different stories. They're different category of bugs. So it's not a broken build. So all unit tests pass. Everything compiles. Yes, you introduce some bugs. You introduce some functionality bugs. But this is what we're going to catch later during the testing, during staging testing. That's a different story.
But these bugs won't break...
These bugs will not break the build. Why? Because no unit tests to break the build. I mean, when you make your changes, maybe I didn't explain it properly. I understand your question. So when you make your changes, and then you introduce maybe some tests, or maybe no tests, then you give it to pre-flight bot. Pre-flight bot takes your changes, adds them to the main master branch, and then runs all tests. Not only the tests you created, but all tests, all 1,000 tests which we had before. And if your changes together with everything we had before, don't really break anything, then we push it to master branch. That's the idea.
And what if, for example, we push it to the master and some other developer would load something on the top of the new feature that I introduced. But this new feature that I introduced had bugs.
Yeah. It may happen, but that's a different question. Of course, it will happen. It's not if; it's for sure will happen. But this is not continuous integration. Does not solve this problem. We're not talking about this. It's a completely different story. We need manual testing. It's a different area of concern. Now we're concerned about broken builds, about automated testing, which could be broken, with static analysis, which could be broken, all that stuff. So the bottom line is that we need to make master branch read-only, which actually I'm very surprised. When I was giving a presentation about this idea, that was, I think, I started first one in San Francisco in the meetup for DevOps. That was 2016, I believe, so about 5 years ago. And all people in the room, when I was saying that master branch has to be read-only, so you should not be able to push to master branch, everybody were just looking at me very surprised way. When I'm giving this kind of talk or discuss this with the programmers right now, like this year, then I ask the question, raise your hand if in your repository master branch is not allowed to be written to, so it's a read-only. Most people raise their hands. So just in 5 years, the situation on the market changed dramatically. 5 years ago, people didn't know that it was necessary. They were just pushing wherever you wanted. Now even GitHub has the feature for protecting branches. 5 years ago, GitHub didn't have that feature. GitHub didn't make it possible to prevent people from pushing to master branch. Now it's possible. Now you can go to configuration, restrict the access to certain branches, and say master branch is only for the robot. Only robot can push to master branch. Before, it was not possible. So the world changed a lot. So now you have this as a good practice. Now it's like everywhere, most people understand that master branch has to be read-only, so we should not allow programmers to push directly to the main development trunk. Okay, and now we're going to talk about continuous delivery. I took this slide from one of my presentations I was giving 3 years ago at the Joker conference. Continuous delivery. Continuous delivery, it looks like this. On the left side, we have programmers. Programmers put changes to repository. From repository, automatically, the yellow line, the yellow arrow, the white arrow, the white arrow, this is the tool, some robot, takes the code and places to the staging environment. Staging environment is where testers can look at the changes and try to break the product. Testers try to break the product and find as many bugs as they can. So they are kind of breaking, crashing, trying to do some penetration testing, do some security testing, whatever. Testers are focused on breaking the product. And then the final step, the robot takes this code, takes this product, and puts it to production. Production server or production platform, whatever. And then end users start looking at the product, start using the product. So this is called continuous delivery pipeline. Pipeline is like steps which should happen, ideally should happen automatically in order to get the product from the hands of developers to the hands of users. And there is a big red line, red arrow, which demonstrates that we have to have instruments and tools configured and processes configured such a way that they prevent the code to go in the right direction and tries to push it always back to the left direction. So continuous delivery has to be configured this way. All the robots, all the instruments have to be configured that way so that push back the changes. We programmers have to be interested in making changes to the code, and everything, all the instruments which we have, they have to reject us. Reject as much as possible. And I will tell you right now how exactly it looks, what it is, reject. But before I recommend this book, which says, the quote which I usually present, the quote says that each stage of a build pipeline Well, they call it build pipeline, delivery pipeline, there are many names. So each stage of a build pipeline is looking for reasons to reject the build. Looking for reasons to reject. So the pipeline which you configure, it has to be against you. It has to play against you. It has to look for reasons how to reject your code. Something is broken, you didn't write a unit test, you didn't write enough unit tests, maybe you forgot something. So always trying to push you back. This is how we achieve quality. Programmers try to push to production, and the build pipeline trying to push back. For example, tests failed, rejected. Lint complaints, reject. Who knows what is lint? Lint, a few people. Lint is the name for tools which they're many, many years old. Lint is the one, probably the first quality control tool. Linter, or lint without linter, just lint or linter, is the tool which looks at your code and says where your code formatting is wrong. Like how you can improve the formatting. For example, you say, A equals A plus 1. But the tool will say, no, say A plus plus. This is better. So this is linter. So linter mostly cares about the way you format code, or maybe some small, minor grammar changes. Or maybe, for example, you open the bracket on a different line. So that the linter will say, no, open the bracket here, so move your bracket there. So they say lint fails, lint complaints, rejected. Test failed, rejected. Integration test failed, rejected. Whatever. Try to find a way to reject your changes. And how to do it, I'll explain you. I call it quality wall. Quality wall is like you kind of trying to build a wall between you and the production platform. For example, linters, we just discussed. Linters, for any programming language, you can find your linters. Who of you ever used anything like that? Linters or style checkers? Okay, how did you like it? Huh? They exist in IDEs, yeah, but usually we're talking about, because IDE is something that stays in your computer. But we need to put something on the server there, on the continuous delivery pipeline, so that when you code on your computer, you push it to GitHub, to your Git repository. And then the tool, which I will show you in a few slides, I will show you the tools which will help you to pick your code from Git and then place to production. So something has to stay on this server, not on your computer. So the build pipeline should not trust you, because IDE is you trust yourself. Okay, you write the code, the linter says it's wrong, so you change it a little bit, you push it to Git. What if you don't change it? It's okay if you work alone, more or less okay. But imagine you work and I work. I cannot trust you all the time that you will always pay attention to what your IDE is suggesting you. But if you commit to Git, I commit to Git, but then somebody takes it from Git and checks the code, I know that even if you make some mistakes, there will be the tool which will reject it back. So many people ask the same questions, like, why not IDE? We have IDE, why IDE cannot help us to check the quality of the code? My answer is that we don't trust programmers. We should not trust each other in this area. We always should expect errors. We always should expect negligence, expect laziness, expect mistakes. So people are people. So that's why we need tools which will, linters. Linters is the most primitive, the easiest way to check the code, which are not powerful enough, but they're good. The next step is static analyzers. Static analyzers is something more stronger. Static analyzers, they look at your code and they say, where are the potential bugs? Like, for example, here you use a variable which you didn't initialize before. So probably there will be null pointer exception if it's a pointer, or probably you're making something wrong. Or, for example, this is an array. There are a certain amount of elements in the array, but then there's an endless cycle which places elements into this array. So you never check for the end of array. So probably you can get overflow. So maybe one day you will go over the limit of this array, and so on and so forth. So these static analyzers, they're quite powerful. Some of them, most of the powerful analyzers are not cheap, so they are not free, not open source, but there are some of them open source. For main languages like Java, C++, we have open source static analyzers which can help you make sure that your code has less bugs than before. Unit tests. of course, another part of the wall. So you need to make sure that inside your repository, you have inside your build, inside your script, which builds everything. You know that every time you develop the software, you have to have a script which packages everything together. The script. So when I take your repository, or anybody, or you open the repository, you look at your files, there has to be a script, or maybe a configuration file, which explains how I can, in one command from command line, I can package everything. Always. So if you don't have such a file in your repository, then you're doing something wrong. It's like a mandatory step for designing your product. There has to be an automatic, maybe we need to talk about this more. There has to be it's called automated, build. I don't know how it's the right name. There's a build manager, and the build manager has to be configured so that you automatically make a build. So it has to be an ability for anybody to build your software in one click, in one command line instruction. I just say build it. Maybe I need to use Maven, maybe I need to use whatever, Gradle, something. No, everything we discuss right now are elements of the build pipe, of the build script. So the build script only just puts together linter, static analyzer, run the unit test, compile everything. So this script turns a collection of files into a package. So if without this script, your product is just a collection of files, you need to have a script which builds everything together. Without such a script, it's not a product. So for your lab projects, also think about this. So you need to make sure that there's a one-line command which puts everything together. And when it puts everything together, it runs unit tests, static analyzers, linters, everything. So it doesn't build if there's any mistakes. It has to reject it. It has to stop building if there are any mistakes. It has to reject. It has to try to reject. That's why you need to make your build as strong as you can. That's the strength of your build. The more fragile is your build, the easier it fails, the better. So you need to you need to design your build the way that any mistake it sees, it immediately breaks. Any problem, something is improperly formatted, something is not properly covered, we're going to discuss it as well, the build fails.
What does this file usually, how is it usually called?
It is how we design products. Yes.
No, I mean, how is it called, for example?
How what?
How is it called, this build file?
How is it what? I can say again. How is it called? What's the name of this? Build. Just build. Just automated build. Build automation. Software build automation. That's the name.
He was asking for a brief file name.
No, it depends. Yeah, it depends on language. Yeah, if it's Java project, I would recommend Maven, even though some people would say that Gradle is better. But I would recommend Maven. If it's Ruby, then it's Rake. If it's Go, then Go has its own build automation tool. If it's PHP, then it's Composer. It's If it's JavaScript, then probably it's Grunt or something like that. So, say again. Python. For Python, we have
Setup tools.
setup tools, probably. Yeah. I think for Python, we design it every time something on our own, like a shell script. No?
No, there is the PyPy registry.
PyPy is the dependency manager.
There are setup tools
Setup tools.
that help to build those packages. If you don't
Yeah, but can you configure setup tools to run linters, to run unit tests? That's the question. I remember that for Python last year, I was doing it manually. So I was just designing bash script, which just also I would recommend you if you don't have an option, use make. Make is the number one. I use it every day. Like these slides, which I designed in LaTeX, they are made by Make. So I build them using Make. I think Make is the most powerful tool, the number one. It's on the market for 50 years. You just need to learn how to use it. It is extremely old. It's the oldest. It's older than C++. It's in C. It's older than C, yeah. It's coming from Unix time, yeah. Make is number one tool. It has tons of problems. Use CMake, it's more powerful, but I love Make. Yeah, yeah. Make is for everything. So I use it for LaTeX, for example. I use Make. For large projects, for something which is more complex than just a few files, I use Make. I'm not an expert in Make, but I suggest you to learn it. Next one is integration tests. Some people say that there is no difference between them, integration tests and unit tests, but we're gonna have a lecture in 2 weeks about unit testing. We'll discuss the difference, but now just trust me that you need unit tests and you need integration tests, both of them in your build script. Then test coverage control. Do you know what it is? Test coverage control. You probably, say again?
Test which tests the test.
The test which tests the test, more or less. When you, again, we're going to discuss it later in details, but in short, when you have your files, for example, in Java, and then you have the tests which try to, which do something with these files to test them, while they work, these tests, they touch certain lines of code in the Java code. Well, I'm saying touch, it means that when the test runs, the execution goes through some lines in the Java code. And then when everything is done, you can look at this. There are some tools which control this coverage. So before running the test, you run this tool, which prepares your code. It's called instruments the code. And then after the tests are finished, then the tool collects this coverage information. The tool will tell you, visually usually, it will show you the original code and will show you the lines which were covered during the testing with green lines. And then something which is not covered in red lines. So the more green lines, the higher is your coverage. I'm not sure I explained it fully correctly, fully easy to understand. But again, we're going to talk about this later. The bottom line is that the higher the coverage, the better. So the more code your unit tests cover, the better. And inside your build script, you can check this coverage. You can say, if my coverage is lower than 80%, the build fails. In this case, it will be quite strict build, because it will reject the code if the build, like this example, I write my code, but I forget to write the test. What happens? Coverage goes down, because I introduce new code, but there's no coverage, no unit test for this code, then the build will reject this change, which is good. And finally, there is an interesting thing which is called mutation coverage control. Mutation testing, again, we're going to discuss it. I'm sure nobody knows what it is, mutation testing. It's a very interesting concept. You can Google it, and we will discuss it next lecture. So it also can be controlled, this mutation coverage, which I believe, and many people believe, is even more powerful, much more powerful than just test coverage control. So this is quality wall. Yeah, and of course, manual code review. This is aside from the script, of course. So you need to make sure that code reviews are absolutely mandatory in serious projects. So when you do like serious development, when you will do development of projects in production, in companies, then you always need to remember that manual review is an excellent opportunity to reject the code. Manual reviews are necessary to reject the code, not to accept it, not to tell your friend that the code is great, not to just demonstrate how smart you are and how much you know about the code to teach somebody. No, code review is to reject. Reject. Say, no, we're not going to accept your code because it's so and so. Okay, now we're talking about Git. We're talking about continuous delivery. So let's discuss where we deliver to. I know a number of platforms where this delivery is happening to. So how do you deliver it? Where do you deliver the code? First one is static websites. Do you know what it is, static website? You probably need to know what it is. Static website is like very new, well, not really new, it's about, I don't know, maybe 7-8 years old, trend, maybe 10. 10 years ago, in order to design a website, what we were doing, we were making PHP front-end, HTML, PHP, maybe some PHP, it's not a front-end, it's a back-end, like PHP, some files in PHP, which were generating HTML. Then we were renting the server. On the server, we installed these PHP files. and then people go to the server, the PHP engine generates the HTML delivered to people, people look at this HTML, everything is great. But then all of a sudden, some time ago, 10 years ago, people realized that some websites don't need any engine to be run live. So we can pre-generate all of the files one time, just run some engine which will generate all HTML files, and we will just place them statically on the server, and the server will just give it to the users. For example, my blog is designed exactly like this. So you can go through my blog, you can click on the page, and it will look to you like there is some machine there, which thinks, okay, you click at the section here, you click at the chapter here, you go to another article, and each time the article is being generated, maybe from the database, like built for you. But no, all the pages are HTML pages. They are generated statically one time and then automatically deployed to GitHub Pages. GitHub Pages is a platform where you can place your HTML files and then configure the URL, configure the domain of the website, and GitHub Pages will start showing these files to end users. So you can design your blog, you can design your site for no money because GitHub Pages is completely free. So you pay no money for that. You just put HTML files there, find out how it is, like how it's configured. It's not so difficult. And you will get your own blog in just 5 minutes. You don't need any engine, you don't need any database, you don't need to rent a server. It's a completely free operation called GitHub Pages. So you prepare everything statically, you deploy it to GitHub Pages, and it's done. That's one of the target platforms where we deploy. I mean, I deploy my blog to GitHub Pages.
Then isn't it super easy to load any static website?
It's easy, it's super easy for many static websites here. Most websites right now are static. People just found it out 10 years ago, realized that many sites don't need to be dynamic. So in many sites you don't need to, because usually traditional design was like this: database, PHP engine, and then HTML, not the front end, but request comes to the PHP engine goes to the database, retrieves the content of your blog, then renders the HTML, returns the HTML. And then the question is, why every page render this content over and over again, if we can generate it just once?
It's funny how all of the websites are written like this, it's like that. So,
Yeah.
so it's kind of very strange.
Yeah, originally it was designed like this, exactly. Originally when we started from the websites, there were just HTML pages. But then people started with this CGI, that was the technology. I don't remember what it stands for. CGI, interfaces, common something interfaces, yeah, common G interfaces, CGI. When people were able to inject some code inside HTML, which, common what? Common gateway interface, yeah, which opened an opportunity for a lot of security loopholes actually, because you can imagine there's an HTML page and then the bash script stays right inside the HTML page. It was quite dangerous. And then the PHP showed up, and then the databases, so it became like complexity was growing up on the websites, and then it dropped down when we have static websites. So for example, Wikipedia. So Wikipedia, every time you go to the Wikipedia page, the Wikipedia goes to the database, retrieves the information from the database, renders HTML, and gives it back to you. Why? Because we want to go to the database and edit this stuff. Many people go to the database and edit the Wikipedia pages. But in case of my blog, I don't have many people. I have just me, and I keep all the sources of the blog in GitHub. And when I click continuous deploy, and when I want to deploy, I have a script which compiles all the pages. I have maybe 400 pages on the website. It takes about 20 minutes. So it compiles all my pages from Markdown to HTML, and it builds 400 HTML pages, deploys them to GitHub Actions, and that's it. And then when you go to my blog, there's no connection to the database. You just immediately get the HTML page, and it's super fast. That's the beauty of static websites. I'm showing you this because because this is continuous deployment. So I do it with one click of a button. You can go to my blog, the sources, and you can see the recent issues. You will see the script, how it's running, how it builds all these pages, and continuously delivers to one of the platforms, which is GitHub Pages. Another example where you can deliver is libraries. So when you have a library, then you're going to deliver your stuff to Maven Central, RubyGems, NPM.org, and so on and so forth. So if you develop not a website, but you develop a package, a library for some programming language, then you will probably deliver to one of those platforms. Also continuously. Also, you will need a script which builds everything and then connects to this platform and pushes this stuff to this location. How to do it? Again, I would recommend you to, well, you can Google that, but you can also check my blog, How to Deploy to Maven Central. You'll read the information. If you have a small web application, I can recommend you Heroku or open source alternative called Doku. If the application is small web app, then you can deploy to Heroku. Who knows about Heroku? Cool. You know Heroku. It's San Francisco-based company, acquired by Salesforce a few years ago. Very, I mean, it's a very, very good and very expensive platform. Super expensive, huh? Free plan. Yes, it has free plan, but with free plan you have no SSL. So HTTPS will not work. Yes. So if you design something, well, you can do for free. Well, there are two problems. For free, it will shut down. It will shut down any possible moment. So the moment traffic stops, they shut down your application. Then when the first click comes back, then the application starts again. But it takes about, half a minute or something. Depends on your application. If it's fast, it will start fast. But they try with the free plan, they try to shut down your application as frequently as possible. That's one problem. And second problem, if you want to make HTTPS, so enable security for your web pages, then you have to pay, you can do it for free, but you have to switch to the paid plan, which is $20 a month. So $20 a month, you're going to pay for application.
So, looking at this website, it says the cheapest plan is $7 and it includes SSL.
Includes SSL for $7.
Public plan.
Maybe my information is 1 year old. So last year it was, we were paying $20. Now maybe $7. Okay, it's good. Then it's much better. But still, for $7, you can rent a full server on your own. So you can go to DigitalOcean and get a server for $5, which will be larger and bigger than Heroku. So Heroku gives you the automation. The deployment to Heroku is one command line, git push, Heroku push. Heroku, I think it's Heroku push, or even git push. Yeah, it's git push. So you basically have the repository, you keep all your files locally, then you do git commit and then git push, and the connection is made to Heroku. You push all the sources to Heroku. Heroku understands what is the programming language. Heroku makes the build, starts the server for you, and runs your application. The full magic happens right there on the server. It's a really powerful platform, but very expensive. So if you go to larger servers, you can pay hundreds of dollars every month, but you get the full automation of everything. It's really powerful platform. Or you can make your own Heroku called Doku. It's completely open source, so you get your own server for $20 a month, then download Doku, install it, configure it, it starts working, but you will be responsible for resilience, for availability, for everything. All the problems are yours. But it's very similar to Heroku. I run both. I use Heroku and Doku. So that's the platform to deploy. And if you have a bigger web app, if you have large big app, then maybe you can consider Amazon Elastic Beanstalk. Elastic Beanstalk, it's quite large platform for deploying applications, also automatically. So it enables continuous delivery. You just configure a script on your site, on your server, then you just automatically deploy to Amazon Beanstalk. The Beanstalk can start many servers for you, the database, the server, the virtual private network, many things. It starts for you automatically. The next option for deployment, if you do mobile app, is TestFlight. TestFlight, as far as I know, I'm not really an expert in mobile development, but I know we used it for a few applications. TestFlight is like a platform where you automatically, continuously deploy stuff, and then this TestFlight is integrated with, for example, Apple Store, and then you can, from TestFlight, you can automatically somehow move to Apple Store. Why did I show you these target platforms? It's just an illustration, just an example of where you can put your code in a continuous deployment manner. So automatically, you click one button and it goes automatically. All of these platforms, they support it. Now, as I told you, most platforms are making themselves ready for continuous deployment, for deployment in one click. Now versioning. Versioning, another aspect of continuous deployment. Every time you're going to deliver your code, continuous delivery, every time you're going to make it to your users, you're going to give versions to your product. I can suggest you 3 options, like 3 methods of versioning, which one of them you can use. The first one is simple: snapshot, alpha, beta, final, and that's it. So these 4 definitions people use quite often. Alpha, snapshot means something which we develop now. Alpha version means something which is more or less ready for testing. Beta versions means something which is ready for users to look at, like beta users. And then final means something which is ready for the market. So something like that. There's another approach which is called SEMVer. SEMVer, I don't know how to read it. It's semantic versioning. SEMVer, semantic versioning is you can Google, you can not Google, but go to the website semver.org. Read about this. This is like a notation for versioning software. Highly recommend to use it. There's 3 numbers, 1, 4, 17. For example, 1 is the major version, 4 is the minor version, and 17 is the bug fix. So when you release the product, you define this is my main version. So you start from 0 usually, 0.1.0. This is your first version. If something is broken there and you fix the bug, you say 0.1.1. My first bug fix. You make another bug fix, 0.2. If you make a some new features, you say 0.2.0. If you make some major release, which means that you introduce functionality which breaks the functionality of the previous release. For example, you had some API, you had some classes, you had some methods there, but you introduce a new version which people will not be able to use with their previous code. So they will need to change their code in order to use your code. Then you introduce version number 2. Well, number 1 in this case. It was 0, the major version. In our case, it was 1. Then you increment the major number, which stays on the left side. And so on and so forth. There's another idea which is called zero versioning, zerover.org, which says that we should never go above version number 0. So always stay, and there are many products on the market which claim to be in version 0 for their lifetime. So we never go over version number 0. We just 0, 0, 0. We only increment the second number. If I'm not mistaken, you can go to the website, you can see very famous big products. So maybe it's like a fresh trend, it's a hype. So maybe you can, because traditionally if you work in a company and if you suggest to your management that you're going to use some library which is in version 0.0.1, then most probably it will be rejected because it's too early, so the version is not mature enough. So they will be looking for version 1, version 2, or version 7. That means that the product is super mature. But some people say, no, we're going to stay in version number 0 forever. Just why? Because we are trying to rebel against the management idiocracy. I don't know.
How about each minor releases is major? So we will have 117 versions. Management will, wow, this is so refined.
Yes. It's more like it's anecdotic situation, but I'm just telling you that it exists. So people, make fun of this and they exist.
Where usually versions are mentioned?
Where versions are mentioned? Everywhere. So it's good to version your software in general. It's very good practice. So every time you deliver, even if it's a website, it's a good practice to always have versioning, always for yourself. Always give names to give numbers to what you develop. So don't develop continuously. Don't develop like we just develop, make milestones, make versions and say this is version 0.1, 0.2, 0.3. So make steps, make stops. Don't develop continuously without versioning. That will only hurt you. Even for yourself, in GitHub there's a good feature. You can go to the button called releases, click the releases, and every time you see something more or less stable, then make a release. Fix it for yourself. Then tomorrow you will be able to get back to this release. You will be able to compare your releases. But if you develop continuously, then you have no opportunity to compare your progress and see what happened before. Now the tools. What are the tools which will help you with continuous integration, continuous delivery? Tool number 1 is Jenkins. Jenkins, before it was Hudson, now it's Jenkins. Yeah, nobody likes it anymore. Well, it's for enterprise, I believe, for enterprise situations. So when the enterprise cannot use GitHub Actions, the enterprise cannot use GitLab.
About GitLab, we have some post
About
GitLab.
GitLab, yeah, GitLab is another option. Yeah, so I'm just telling you like chronologically. So Jenkins is the quite old tool. Yeah, it's very popular in enterprise. It's large. It's very configurable. It's hosted. It is open source, so you can download it, install on your server, and it will help you automate your continuous integration, continuous delivery. So this is the robot which will take your code from your Git repository, run the build script, and then make sure that all the reports are presented. That's probably it. The second option is 1 million hosted services like Travis. So if you go for Travis, Google Travis CI, that was after Jenkins. They showed up on the market, I don't know, maybe 10 years ago, maybe less. Travis is very good. You don't need to pay for anything. For open source projects, it's all free. So you just configure it there, you give it the script, and it will run the script and give you the badge. Everything will be nice. Another option is GitHub Actions, which is now ruining the market, killing everybody else. So all the continuous integration tools will be dead, I think, in a few years, like Travis, because GitHub Action is completely monopolizing the market. GitHub Actions, very good. They're very nice. They're based on Docker. So you configure your build pipeline using Docker. It's very, very convenient. Multiple Docker images you can use in one pipeline. And my tool, Rulter.com. That's the one I designed 7 years ago. I use it in my blog, for example. My blog is deployed using this tool. So I use this tool for the last 7 years. No problem. It helps me deploy all my products. I deploy to GitHub pages, to Heroku, even to Amazon Beanstalk I was deploying. So Rulter.com, you can try it out. Go. It's also open source, actually. It's hosted on Heroku. So you can enjoy it if you like. It is designed specifically for continuous integration, continuous delivery. One last point I wanted to say about continuous deployment and continuous delivery is that you need to know is blue-green deployment. Do you know what it is? Probably not so many of you know. Blue-green deployment is the concept which is demonstrated on these pictures. In a few words, it works like this. I have the code, the next version of the product, and I wanted to put to production. I go to my script, connects to production, and says, here's the new product. It gives the product to production server, but production server is getting hundreds of hits of users every second. So I cannot just go there and there, with the running server, change the software. It will break the product for a few minutes or maybe a few hours, depending on the size of the product. So I cannot go this way. So how they do it, they say the script, which does the deployment, it goes to production and says, currently what is working now, we call it blue. It's a blue platform, blue version. Then we deploy to a new place and call it green. So now we have two applications running at the same time. Then I check whether the green one is really green. Does it work? So I make some tests, like general health checks. Does it work? Does it open the web page? Does it answer the simple request? Everything is cool. And then I switch my router from this to this in one click, like boom. And then all traffic starts coming to this one. And then I shut down this one. Just kill it. This is called blue-green deployment. From blue to green. And this is how really proper systems have to be deployed. So you cannot deploy just like in Heroku, just one hit, boom, git push. Well, actually, Heroku does it. When you do git push to Heroku, Heroku does blue-green deployment. Heroku starts you a new server, makes some checks there, and then shuts down the old one and switches the root. So I'm wrong about Heroku. Heroku does exactly this. So this is the right way to deploy your software in blue-green deployment mode. But as the slide says, it may not work with databases, because imagine you have one server which works with the database, and people get their transactions coming, people make changes to the database, then you start another server which, for example, differently interprets the data in the database, different scenarios, maybe it even changes the database. So there could be very ugly mechanism. I was working once in a large project where we were doing green-blue deployment with a full copy of the database. So we have the old server, the old web system, the old database with terabytes of data. Then we need to deploy it. We make a copy. We first of all, we set the website in read-only mode. So all users stop making any changes. So they still can come to the site, but they cannot update anything. So everything is on read-only. We were doing it at night. So read-only mode, everything works, but read-only. Then we make a copy of the database. Boom, full copy. It takes like 20 minutes. Like very fast copy from a large database server to another database server. So we copy everything. Then we start a new version of the system. Then we check how it works. If everything's cool, then we disable this system, we shut it down, and we redirect people to this system, and it starts working. If something goes wrong, then we kill this system, we re-enable this one, and then we go back to the office and think why it didn't work. So it's a pretty safe way of deploying, but this is how it works. We all wake up at 3 o'clock in the morning or 4 o'clock in the morning. We're sitting online from home. I remember I was doing this probably 5 years ago. Everybody, like 5 people sitting in Zoom, talking to each other. Okay, what's going on? Did you turn it on? Blah, blah, blah. Did you make a copy? Hit this, hit that. The database administrator, web administrator, they're all checking, testing. Everything is cool. The deployment, every second time it didn't work. So one time it works, next week it doesn't work. Usually it happens on Sunday or Saturday. So in the weekend where the traffic is slowest, so it's in the middle of the night, it's terrible. This is the reality of continuous delivery. So every time we were suggesting, let's automate this. Let's make it a script. So I just click the button and we just watch it like this. That's super difficult because every time some new situations coming up, but we were not ready to invest enough time and money into really automation. So that's why people were doing it half manually, half automation. So some scripts were helping us. Of course, we didn't copy the database manually. There was a script doing that. But overall procedure was manually organized and managed and controlled. Which is a shame. It shouldn't be like this. It should be one click or a button, you click it and you just observe what's going on. Like I said, the copy is made, the systems are, validated and everything like that. Okay? Okay, now the final slide, which I wanted to show you how to develop in GitHub. You asked me to tell you about this. I made 2 pictures, one slide, because it's difficult to put them like this. So I made one on the left is like the top of the page. It's a library which we developed for the last 3 or 4 years. It's a Java library called Cactus. The GitHub, if you don't know how it's organized, I can tell you a few important things which you need to know. So on GitHub you have sources, of course, like normal Git sources. Then you have issues and pull requests, which you absolutely must use. So every time you want to make some changes, you have some ideas, you start with an issue. Even if you develop the project yourself, even if you're the only developer, you try to discipline yourself. You go to the issues, you click the button, create a new issue, explain what you're trying to do, and then everything you do in your Git commits, you mention the name of the issue with the hash sign in front of your text. So every time you do git commit, in the comments you say hash and then the number of the issue. GitHub will link your commit to the issue and you will see how you track your changes. Next step, pull requests. It is highly recommended that you develop in branches, even if you're the only developer in the code, even if you're alone working. Like make it a habit for yourself. So you have the master branch. Every time you start making a new feature, you do git checkout -b and then the name of the branch. It's better to have this name named after the ticket which you create, after the issue. So first you make an issue, explain what you want to do, then you make a branch with the same name as the issue, then you make changes in the branch, then you push this branch to repository. GitHub will automatically suggest, okay, it's time to make a pull request. You make a pull request, and then you merge that pull request. So that's the discipline of development. Just learn it and follow it, my recommendation. Next one is releases. We already discussed that. So in GitHub, there is a button called releases. You click there. GitHub is suggesting you to make releases, and each release, basically, it's a tag in Git repository. The tag is something you attach to the commit, and then you can easily get back to this tag. Basically, tag is a name of the commit, just a more convenient naming of a commit. So you can refer by commit, but commit name is too long. So tag is a short name which you can remember. For example, tag 0.1.5. This is the tag. GitHub will help you to do this if you go to release place. Next one, what is interesting is, I don't know what packages are for. You can find it out yourself. I never used it. I know, okay, the license. Every repository has to have a license. Probably you know that open source world is all about licenses. And each time you put something for people, you are supposed to attach a license to it. So you have to say on what terms and conditions you allow somebody to use your product. Is it completely free and they can take your software and say, this is my software, and sell it for money? Or they should not do this. Is it okay if they take your product, change a few lines, and say, now it's my product, and sell it? Is it okay or not? You have to say it explicitly. So you have to write it down when you publish your code in open source. Then people expect you to put the license there. And there are a number of licenses which already were created by the community. For example, MIT license, GPL license, Apache license. There are a number of them. There are actually many of them. I don't even know their names, but I know a few of them. Some of them more restrictive, some of them less restrictive. So some licenses will say, you are allowed to use my code only if you mention my name always. So you don't rename my name from the code. Take my code, use it, I don't mind, but make sure there's my name. Another license says you can take my code, use it, but make sure there's my name and make sure your code is also open source. So you cannot take my code and use it in your product and sell it for money. No, 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 no. Only take it, use it, I'm okay, but make your product also open source. But some licenses, for example, MIT says, whatever, take it, use it, do whatever you want, I don't care. But you have to mention the copyright note, yes. This is the license I use everywhere. That's the simplest license, MIT. Like whatever, do whatever you want with my software, but make sure that my name is there.
How can you prove, for example, that this code, like, what do you mean by this code is mine? I mean, okay, you have implemented, but like, cannot I say that I also wrote the same code? If I just, for example, something like copy pasting the code.
Well, if you take my code and if you publish it somewhere and you say that this is your code, well, it's not, well, some people are gonna be offended by that. Some authors, they may not like that. So that's why they say, no, my license does not allow you to do that.
Yeah, I mean, but like how to prove that this is mine?
Who will prove?
I mean, this license thing, isn't it something legal?
Well, it's legal. You can sue. Yeah, you can sue people. If I wrote the code, I put the license there, then you take my code and publish it and say it's your code, I can sue you. Yes, and I can get money from you because the license says no, you cannot do that. You can always say it's my code. I mean, it's written by me. It's not my code. The author is me. Of course, it's not like. I mean, it's difficult to say what is what does it mean, what is mine, but it's written by me. I'm the author. Something like that. So it is very important that your code, even in your lab projects, which you do right now, I suggest that you create a file called license.txt. So the file license.txt has to contain the text of the license, which you can find on the internet. Just Google different texts. They're all presented. Don't need to invent your own license. Just take the text from somewhere and put it in the file, and you will be fine. And the GitHub will automatically understand what is your license. So in my case, I take the MIT text, I put it in the file, and GitHub automatically says, oh, that's an MIT license. Without a license, it's not really an open source code because most people will be, some people will be scared to use your code now because who knows what kind of license you're going to put tomorrow. So if you don't announce your license right now up front, then people will be, especially people who work in large companies. So when you stay in a big company, you are not allowed to take whatever you want. You need to pay attention to licenses.
Regarding licenses, you say that you use MIT license everywhere, but your project Zerocracy actually has a different license.
Yes, Zerocracy has a different license, yes. But that's a special case because we didn't want Zerocracy to be really copied and reused anywhere. So that's why we put more restrictive license. But all other my projects are MIT.
The best thing is that you, like in the license, you prohibit people from modifying the software, but in README, you state that if you want, you can modify it, you just create a pull request.
Yes, yes. Through pull request, it's okay to modify. But I'm not sure that actually modifying through pull request is actually modifying the software. Because you don't modify for your own, you don't take it and modify it, you help me modify it. So pull request is not, but it's hard to say.
You also have to copy it, like.
Yes, you have to copy, you have to make a fork, yeah, so you make,
And it's also.
yeah, I'm not sure exactly what's right here. Okay, the licenses is good, so you need to know about this. So be careful. The licenses is a territory of, it's a legal issue and you have to be careful. So it's better to put some license to all of your code. I even do it for all my files. So all my Java, Ruby files, they all have this boilerplate code on top of the file. So I don't write the code, I don't start with the Java code. I usually always place the comment, the full license goes on the top of the file. Because it's not enough to have a file just at the repository. Some people can take your file, just one file, and think about reusing it. And if there is no license attached to the file, then they don't know who is the author, like where the file is coming from. So it's better, I believe, it's a good practice for each file, for each source code file, C, Java, whatever, any language you use, on top, make a comment, and in this comment, put the full text of the license. It will take like 20 lines of code, maybe 25, but it will look more professional. That's how I do it. Okay, that's it for GitHub. Let's talk about books. Some books, the two books, oops, MDA explained is not relevant to it. The picture is wrong, it's not MDA explained, it's release it. So I put the wrong image here. So two books, Continuous Delivery, but by Jez Humble, very good book. It's the #1 book actually in this area, Continuous Delivery, highly recommend to use it. It's a little bit too long in my opinion, but it's very important to read it. And the second one is Release It by Michael Nygaard, also very good. So if you want to publish or be popular, like instead of a conference, I suggest you to put yourself a goal, collect 1,000 stars on GitHub for some project. If you can achieve it, I can guarantee your life will change. So if you can get 1,000 lines of 1,000 stars for your GitHub product, remember I told you about EOL language, which we designed, EOLang, right, which we do. 4 days ago, we got on Hacker News, on the first page. And we got 70 stars in just one night. It's not 1,000, of course, but 70, yeah. I just found out, I just went to repository and said like, how many, why, where the stars are coming from? And then usually it's Hacker News. So Hacker News is your way to promote your product. Remember this, Reddit and Hacker News. There are two sources of promotion, two places for promotion. Reddit for the Reddit programming, reddit.com/r/programming, and Hacker News. So if you make something interesting, some valuable product, go to both of these platforms, post it there. If the community picks it up, if the community likes it, you're going to have 100 stars next morning. Sometimes even 200 stars. So aim for 1,000. Once you have 1,000, you're a programmer of a different class. You're a top elite programmer, because I don't know how many people in Russia here have 1,000 stars, maybe, I don't know, 40 people, 50 people in the whole country. That's how many programmers, Russian programmers, have repositories with this amount of stars, maybe even less. Yeah, I have one, yes. No. EOLang is 550 now. I have Tacit, it's a CSS framework for CSS. It has 1.5 thousand, something like this. Okay, call to action. So what do you want to do? I suggest you set up continuous delivery pipeline in your application so that it's released to production automatically on each commit to master. Just take your lab project, configure your delivery pipeline, and make sure that every time you commit something to master, it gets, boom, packaged and released to production. If you can do this, you'll be the master of continuous delivery. And I suggest to use GitHub Actions for this. It doesn't say it in the text, but that's my recommendation. Okay, finally, so what is not resolved right now? My final slide, we have 2 more minutes. First one, how to, when we do testing in this build pipeline, I think in general, it's a question, very interesting question, how to parallelize tests. Because builds are usually taking time. And long build is a huge problem. When your build script is running for 5 seconds, it's okay. If it's running for 5 minutes, it's still okay. But if it's running for 5 hours, it's not okay. And people think how to turn 5 hours into 5 minutes. And the one possible way is to parallelize tests, to run tests in parallel. How to do it, it's in general a question, some primitive approaches exist, but the more complex way is difficult. Second one is how to speed up merging into master. Like we discussed, we have this pre-flight bot. But the problem with the pre-flight bot is that it can only process your branches sequentially, one by one. So if there's a team of 20 people, and all people make like 2-3 branches every day, then you're gonna have like 50 branches every day. And if each branch merging takes half an hour, then it will be impossible to merge all the branches during one day. I've seen these problems in real projects. So how to solve this? How to make it faster? That's in general a big question. More workers, but still you cannot push, you have to wait for half an hour while we test your branch, because nobody else can do anything now. We need to wait before this one gets pushed into master. And then we pull from master, and then we start testing the next one. So we cannot do it in parallel. That's just a fundamental constraint. How to resolve it? I don't know. We tried. I don't know how to do it, theoretically. Second one, how to generate tests automatically. So very often we have legacy systems, a lot of code. We want to improve the build, so make it stricter, reject more. The question is where to get the tests. Mostly people don't write tests. So how to generate tests from the code. That's a huge research territory. We, in the people who I work with right now, I know a number of teams who do this, who work on this, how to generate tests from the code. So it's a research direction which has not so many answers right now. And the last one, how to enforce quality for legacy code base. When you join the project, you will see it in real products, in real companies, you join the project, there's a legacy code. And legacy code has completely ruined code usually. I mean, the quality is extremely low. And the question for you will be, how can you enforce the quality? How can you increase, how can you, first of all, fix the quality so it doesn't go lower? And then how can you start increasing the quality on large code bases? Like how, for example, you run the linter, and linter says there are 5,000 mistakes. What do? You're going to fix 5,000 mistakes? Nobody will fix that. No programmer will want to do that. So how do you do, how can you? We are thinking about like one research direction, for example, we look at the code, and from the code we configure the linter the way that it doesn't show all the 5,000, but say, okay, 50 errors. The rest is, the linter will just learn that this is your way of designing code, something like that. So the linter will be smarter and will forgive you for something. But that's for the future. The answer is not known.